Assalamu alaikum guys. Hi everyone. Welcome back to our quadcopter design tutorial. My name is Ayman and today I'm gonna guide you step by step on how to assemble all the quadcopter parts. And as you can see here, this is our partial final product after it's been ready for assemble. As we can see from the part 3 on the left hand side, these are all the existing parts that have been imported into the assembly file. And how we get to the assembly file, we have to go to the start menu, mechanical design, and then scroll back down to the assembly design. And after you left click this button, this screen will just pop up with all the options, functions, and tools associated to this design platform in CATIA. Okay, so first of all, we will start on how to import existing parts. First of all, you must have all your parts and all the parts must be saved in the same file or the same directory. So this will enable CATIA to easily restore all the files and import them into the assembly file. Okay, so first of all, let's assume that we do not have any existing part has been imported already. So how are we gonna import them? As I'm gonna show you, here are all the importing tools. Yeah, the one that I'm squaring around. And first of all, we go to this option, which is an existing component, since we already have our parts has been designed and 3D and saved in a 3D CATIA file. So we already have them in the same directory. So we will hit the existing component and then we will go to the quadcopter, which is the name of the assembly file. And then we left click on it and this screen will pop up in front of us. And then we can select any part we would like to start with to be the main hub, or rather the first part to be established in our assembly design. So for our case, the main hub is as its name suggests, it's the main hub, which most of the parts are going to be attached to. So we have to select it and then click open. And after that, as we can see, there is a hub has been imported. A 3D part model has been imported to the assembly file. And the way how we change or rather move this in the 3D free space, any part, first we have to select this option, which is a manipulation tool. This pop-up window here shows you all the possible degree of freedom that any part could move. Let's say first we want to move this main hub that we imported just now in the Z direction. And what we have is just to left click on it and then drag up and down since it's moving in the Y direction. If we want to move it on the X direction, we will click the X and then move upward and inward. Rotating is the same thing. Let's see, we want to rotate about the Z axis. We hit this icon and then we rotate about the Z axis to any desired location. Okay, that's how we import our main hub here. And just to establish the idea that this is going to be the main hub for our or rest of our parts to be attached to, we will have to constrain all the main parts to it. But first we have to select this icon, which is the fixed component, and we will choose our main hub to be the fixed component. So now our main hub is the fixed component here, and it cannot be moved in any direction. So now we will just remove our demo, and then we will resume back with our main hub, which already been fixed at this particular point. Okay, and then accordingly, we will import, let's say, the arm at the beginning, and then we will position it in such a place where we can easily constrain it with the arm attachment extended from the main hub. And to do so, we will start by the coincidence constraint. And this one, as we can see from the pop-up screen, after we hit this coincidence constraint, we have to hover above the hole that we wanna constrain. As we can see from the icon, it is an axis constraint. So it just constrains the axis of any hole, shaft, cylinder, or any cylindrical shape generally. So after we hit the constraint icon, then we hover the mouse around the hole that we wanna constrain our part. And then it's quite tricky to get the axis of any hole. This is kind of a glitch, I would rather say, in CATIA. It's quite hard to select this one. So we click on that axis, and then let's say we click on this hole, the one we want to constrain our part 2. Okay, as we saw, it already constrained the part, but since our parts are already constrained, it just refreshed all the window and then attach all the other parts. So that's how we constrain the part. We click the constraint icon here, and then we select, for example, this axis. Okay, yeah, this axis, and then the axis of the same hole that that is existing on the other component. Of course, these holes must have the same dimension, so you can easily attach them firmly using a bolt or any attachment mechanism. So we have already constrained this one, and then the same goes for the other hole. We will constrain it with this hole until we see this constraint icon appears, which is a circle similar to the icon on the sketch platform. And after that, we will use this content constraint. Okay, so far we already have our two holes constrained to each other, this one to this one and this one to the other one, but they are free in space, like they can move upward and downward in the z direction. So how we just constrain the z direction is that we hit the constraint, the contact constraint, and then hit, for example, this first surface and then the other surface. So it says a similar constraint already exists between the two selected elements, means that we did the same process before. And as you can see, after we did that, the arm will be attached to the arm attachment extended from the hub. And that's how we fully constrain any existing part. Okay, we will hit Ctrl Z, so we'll move them around. And the same goes with the bolt. We will constrain the axis of the cylinder here with the hole with this axis, and then the same goes for the other bolt as well. After that, we will move on to the another part to be assembled, which is the motor housing, and the motor housing will be attached to the other end of the arm. And the similar process will take place from these holes. We will constrain the axis of this hole to the axis of this hole using the constraint command. This axis and this axis as well. After that, the other side, which is this one and this one as well, until we make sure that they both are constrained after this constraint icon has appeared on the screen. And after that, we'll move on to the contact constraint. And then we constrain this lower part of the motor housing base with the upper part of the arm. And after we refresh, we will see the motor housing base has been placed on top of the arm. So we hit Ctrl Z just for demonstration purposes. Here we are doing Ctrl Z and Ctrl Y. And the same goes with the bolts. As we can see, these two small rectangulars shows the surface contact, means that this surface of the bolt, which is the lower part of the head, is being constrained to the upper surface, contactly constrained to the upper surface of the motor housing. Okay, after that, the same process goes to the propeller as well, mainly for the assembly projects. These are the main tools that's going to be used, which is the axis coincidence constraint as well as the contact constraints. You have to use these to make sure that all parts are aligned with each other and the surfaces are contacted with the ones that they are designed to. And as we can see here on the left hand tree, the part 3, these are all the parts has been imported. As we can see, we have 4 arms, 4 motor housings, 4 propellers, and 1 payload compartment, as well as 2 landing arms. And if you scroll further down, you will see the constraint icon here with all these constraints applied on the part. Just hide most of them except for the one that I'm showing right now. This is how you identify that you already constrained your part. Repeat once again, this circle coincidence means that this part is being constrained with this other part using the same axis. These two parts sharing the same axis. They are aligned on top of each other. And this one, let's zoom in so you can see clearly. This one, the rectangular shape here, this one indicates a contact constraint. Means that this surface being constrained, not this surface. Yeah, indeed, it is this surface. The upper part of the arm is constrained to the lower part of the bolt. So this lower part of the bolt will be placed on top of the arm. Okay, and the same goes for all the rest 3 arms. I know it's quite time consuming, but it's worth it. Okay, so we will move on to the payload compartment. As you guys can see, these are the 2 attachment holes from one part, and then this one from behind the other 2 bolts. So we will use the same process. We will constrain this hole axis with this hole using this command, and also this one with this hole, and the same goes with the bolts. After that, we will contactly constrain them. As we can see here, we already made contact. Okay, this hole with this hole and the other hole with the other hole, and the same goes with the bolt. And then finally we will go with the landing arms. The landing arms are aligned with the side holes from the main hub, these main holes, as you can see. So the right arm, this one, the right extension from the arm will be constrained with this hole, and then the left arm extension will be constrained to this hole. And as you can see, the shadow is just the reflection of the extension arm on the top, and where it's going to be placed, this one before it's been constrained. And also we will maintain a contact constraint between this surface and the inner part of the landing arm, which is this one. This one, after it's been aligned with the hole, will be attached to this surface. So when we hit refresh, you will see that it's been in direct contact. The landing arm has been in direct contact with the extension from the main hub, and the same goes for the bolts as well. And we will do the same thing for the other landing arm, the alignment constraint as well as the contact constraint. And the reason why the constraint icons are not shown here is just because I hide them. But if you want to make sure that you already made the proper constraint for the proper parts, then for sure you have to hide and unhide them. So let's unhide them and then we view and make sure that we already constrain all the parts that need to be constrained. Okay, but to double check and to do the most important thing in the assembly design is to make sure that you have maintained all the constraints required without clashing the parts or have some sort of clearance between the parts that are unnecessary. And how to do that is that let's first hide all the constraints and then go to the use this toolbar. It's a space and something. This is a very useful tool, and the reason why is that it allows you to check all your contacts, constraints, as well as the clearance between the parts. So therefore, you will know that if you made any sort of mistakes or clashes, or some of the holes are not aligned with each other, or one of the holes is bigger than the other one, so there is a clearance or gap once you assemble. So using this tool, you will know for sure if you made this mistake or not. So you will left click on the check, and then here we have to choose the type of analysis that we want to perform on our already assembled design. And then we will choose the clearance, contact, and clash between the parts. And then we hit apply. And then the software will calculate all the possibilities of clashes, clearance, and gaps, and then it will report this table for us. And then we can see first in the number of interference, which are 36. And the detailed information is provided is that clash is 0, contact is 36, and clearance is 0 as well. So that means that we have no clashes between all or any of the parts, which is a good thing. And there is no clearance, no gaps between any parts. It means that they all are perfectly constrained. And that's why we have a 36 contacts among all the number of interference, which means that all the 36 interference are perfectly contacted. And this table here, the list of conflict, it shows you all the contact in detail on the left window that just popped up right now. And here we can check the status and the type of a contact, and you can scroll down and check, for example, this motor housing and bolt contact value is 0, status is relevant. And the picture here shows a detailed diagram for the contact process that is taking place between the bolt and the motor housing. And as we can see, nothing is in red, so we are positive that this part is perfectly constrained. And then if you are happy, we say apply, then we recheck again, then okay, and restore the toolbar to its position. And then I think this marks the end of our presentation on how we made the assembly for the quadcopter design. And this is the isometric view for our quadcopter, and this is multi view. This is the top view, isometric view, back view right here, and the side view. I hope you guys enjoyed watching this video tutorial. Thank you very much, and see you again in next tutorial.